Permutations. In the previous session, we learned what is fundamental principle of counting, where we studied the multiplication principle as well as the addition principle. Now let's go on to what is permutation or what is arrangement. So what is this arrangement and how do we do this arrangement? For an example, suppose you have three objects P, Q, R. Three objects are there and you want to select two from that. So you can select that two in different ways. That is, you can select that as PQ, you can select it as QR, you can select it as PR. Also, you can select it as QP, RQ and RP. So you can select in these three different ways, or you can arrange in these three different ways, right? So you selected from this one, that is 2, and then you arrange that as PQ, QR, PR, etc. like that. So how many different ways are possible here? You can say that 6 different ways are possible. 6 ways of what? Arrangement are possible, right? 6 ways of arrangement are possible. And now, how can we use the word permutation here? The arrangement is same as what? Permutation. So when you permute, you what? You do the arrangement. So when there are 3 objects P, Q and R and you want to select 2 and arrange them, you do that in these different ways. Now mathematically, how can we represent permutation? Before mathematically representing permutation, we need to first know about what are factorials. So what are these factorials? A number which when multiplied, when multiplied till 1 can be called as what? A factorial. Suppose you have 5 and you denote it as 5 factorial. I'll show the depiction later. And if I write 5 factorial, it means I need to multiply 5 till 1. So 5 into 3, 4 into 3 into 2 into 1, and that is nothing but 120. So this is 5 factorial. And to represent it, this 5 factorial, we use what? An exclamation mark. So 5, and after that put an exclamation mark, and 5 factorial is nothing but 120. Understood? And now same like that, what will be 7 factorial? It will be 7 into 6 into 5 into 4 into 3 into 2 into 1. That gives us 7 into 6, 42. 42 into 5 is 210. 210 into 4 is 840. 840 into 3 is 2920. 2920 into 2, it's something around. Now, what is the 7 factorial? We know 5 factorial is 120. So this much is 120. And you have 42 into 120. And that gives us 42 into 12, which is 84, 42, 5040. So 7 factorial is nothing but 5040. So that's how you get 7 factorial. Now, in general, how can you represent a factorial? For a number n, n factorial is nothing but n into, then you multiply with a number less than that. So n into n minus 1 into n minus 2 into n minus 3 up to the last number 1. Before that, 3 will be there, 2 will be there, and you finally reach 1. So that's how you find out n factorial. So same like that, what will be 10 factorial? 10 factorial will be 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. You calculate and you get the final answer for 10 factorial also. Understood? Now let's do what is maybe 11 factorial by 6 factorial. What is this 11 factorial by 6 factorial? Can we write it as 11 factorial? You can write as 11 into 10 into 9 into 8 into 7 into. What is the remaining? You have 6 into 5 into 4 into 3 into 2 into 1, right? You have this one. What is the 6 into 5 into 4 into 3 into 2 into 1? Can I also write it as 6 factorial? Yes. And the denominator, you have 6 factorial, so these two gets cancelled and you are left with 11 into 10, 110. Then 9 into 8, 72. 72 into 7 is 504. So 110 into 504, you get it as 504. 504 multiplied, and you get the final answer as 55440. So that gives us 11 factorial by 6 factorial. So understood how to find factorials, and also one question where it is given as 11 factorial by 6 factorial. You don't need to always write it as 11 into 10 into up to 1. You can also write it in this way and cancel the commons. So 6 factorial is there common, I cancelled it and I got the answer. Understood? And now if I have a question here that is x by 8 factorial plus x by 9 factorial is equal to 1 by 7 factorial. How can I find the value of x? We know that x by 8 factorial, can we write x by 8 factorial as x by 8 into 7 factorial? Because 8 factorial is 8 into 7 into something, right? And what is the 7 into number still 1? 7 factorial. Plus x by 9 factorial, I can write it as 9 into 8 into what? 7 factorial. And that is equal to 1 by 7 factorial. Now you might be wondering, why did I write it as 7 factorial or in terms of 7 factorial? Because it's easy for me to cancel. So I can cancel the 7 factorial, 7 factorial, 7 factorial, and left with x by 8 plus x by 72 is equal to 1. And you multiply with 9, you get it as 9x plus x by 72 is equal to 1. 10x is equal to 72. X is equal to 72 by 10, or that is also equal to 36 by 5. You can write it as 36 by 5. So that is the value of x here. So this is about factorials. Now, what is this factorial useful here in permutations? In permutations, to arrange R objects from n given objects. To arrange R objects from n given objects, you can do that by using the formula NPR. And what is this NPR? The formula is like this. It is n factorial by n minus r the whole factorial. So what is NPR? N factorial by n minus r the whole factorial. Understood how we get the formula? So to find out the total permutation of r objects from n different objects, or how can you arrange r objects from the given n objects, you can do that using n factorial by n minus r the whole factorial. Understood? So you have 4 people. You have only 2 chairs. So in how many ways I can arrange these 4 people in 2 chairs? I can do that using the formula NPR, where n is equal to what? N is equal to 4 and r is equal to 2, because you have only 2 chairs. So n is equal to 4 and r is equal to 2, and you can do that using the formula 4p2, which is nothing but 4 factorial by 4 minus 2 the whole factorial, which is 4 factorial by 2 factorial. That is 4 into 3 into 2 factorial by 2 factorial gets cancelled. 4 into 3, 12. So you can do that in 12 different ways. Clear? So this is the basics of permutations. In the next video, you will be learning about different types of permutations. That is, when there are distinct numbers of objects, when you are choosing repetitive objects, when there are all objects which are taken at the same time, etc. Now for the time being, let's just have a quick recap of what all we have learned in this session.
Manorama Horizon. Learning made simple.